Well, I'm going to talk a little about nuclear isolation that we do in plants. Well, for plants, for the first day, this is the protocol that we use for all the plants that we receive from Darwin Tree of Life. We use this protocol the first day, the kit Q protein, and that is the condition of the samples that we have to receive. They had to be cryoprepped, no biomass needed in this protocol. The TC buffer is not required for processing plants for us. And the kit is used for the isolation, right?
This is crushed tissue, right?
Yes, cryoprep with the buffer, right?
And what kind of amount of tissue are we talking about?
It should be around 100, right?
60 to 100 milligrams.
Well, this is the protocol. They use a CE1 buffer, that is a licensed buffer, and different kind of incubation with the Hula mixer. And we use a column to clean this material, and in the end, we work with the liquid that we obtain after the column. That we can just keep the pellet, because we have to obtain the pellet at minus 70, and then we continue with the fixation of the HiC protocol. And first we resuspend in one mill. And the fume cube that you already know how to do, we have this modification that we don't use the TC buffer. And we add at this stage the formaldehyde directly to the samples. Because we don't use the TC buffer, so we add the formaldehyde directly. We incubate only 10 minutes at room temperature, and then the stop solution 2, we add 92 microliters. And it's ready to go to the lysis buffer after that. After of course, the pellet certification and everything. So it's worked quite well. We don't have a lot of problem with plants. Sometimes there are some kind of difficult to obtain when we use the column with the chitin. Some plants are very slimy, maybe, and the way that I resolved that is maybe do several times with the centrifugation. So I try to obtain the most of the supernatant that you can, or I can. Sometimes it's not enough, it's not the volume that we expect, but we continue anyway, and it works. I'm not showing the final bioaccumulation, but in the end, it's not important, because sometimes we have some samples with the HiC, the PLD value less than 0.1, that actually the qubit can read. So it can be anything, but it goes to the library anyway, and it works. So I suppose that depending on the sample you send to the library anyway, because some of the samples are very, very important that we have to do. But some of them, it doesn't work, even if we have enough the concentration. Sometimes it just doesn't work, and we don't know why. Sometimes you can have a very cloudy DNA, final DNA. It's not cloudy, but it's green, and we proceed anyway. So it's not always that our samples are white and nice. We have some colorless samples, and we work anyway.
You said you spin multiple times if you have kind of a mushy supernatant. Do you use the same column between those spins, or do you take a new column each time?
I changed 2 times.
Okay.
I mean, I centrifuge 2 times. If I can opt it, because I centrifuge several times, because I cannot have any liquid. Everything is stuck in the column. So I try to do 1 more time. And if it doesn't work, I can suspect that maybe it's the column or the sample. So I change the column at that point. Sometimes this is still with the same problem. So is that the sample? So I just try to collect everything that I can and work with that. But, it's not common for us yet, maybe. But that is the way that I didn't know that it was going to work, but I did because I had to do something. So yeah, apparently it worked. This is for low input, that you also have the protocol in the folder. It's less than 5 milligram tissue, but less than, with less than 5 milligram tissue, but less than the recommended 5 milligram. Yeah. The Q protein kit is not required in this case, as the samples align more to the standard protocol. And we use here the power machine to successfully prepare the type. So the protocol change a little if it's very low input. If you have any problem, question of the protocol, we can discuss.
Do you see a difference in success between?
Not something that is very obvious. We don't see difference with that.
So you have a high success rate on low input plants.
Yeah.
Without
Otherwise,
the nuclei.
yeah. Otherwise, we are going to receive a feedback that stops you do that protocol.
Maybe they are slow in getting feedback too.
No, they are going to stop. I'm sure that they are going to stop if they found any feedback.
Yeah.
Sorry, any problem. But
A question, so do you consider about the genome size for plant tissue?
I don't think so.
So in our lab, so sometimes we get Arabidopsis, the genome size is 200 megabase. Sometimes it's spruce, it's to like 4 gigabase. 20. That big, huge. Then with the only kit, we apply different DNA. So regarding also input, and also we concerned about the genome size. So it should be combination with different parameters.
We don't take any consideration of that. No, we proceed with any samples of plants. It's working.
But I guess that from spruce you can get quite a lot of the needles or shoots that you can make a larger crop. You do not go into the lower protein, right? So then you can use the same lysate and different libraries.
Well, this maybe we still have very low amount of number of samples. So comparing with the plants that we are processing, we have a lot of plants, so we don't have any problem. But comparing with low input plant, is like I put there, is still in training. So we are training in the lab. We have some results, but probably we are not seeing yet the problem. And it's going to come when we have more number of samples. I don't know. We will see. We don't have good success in lichen. We were working at production with some of lichen. Couple work here. A lot doesn't work here. I tried it last time because I really wanted to receive that sample. So give me the lichens. I can do it. It's not the hands, it's the protocol. The sample is difficult, and it works. But during the course, we received the email from the bioinformatician saying that it is okay, but not the best, and he will wait the result in PacBio to see if they can do the assembly or not. I don't know. I don't know. I'm not a bioinformatician, and we don't work with the bioinformatician part, but he will wait the result from PacBio to see if it's good or not. But he said that it's acceptable. This is the sample that we received. This is one of the samples that it didn't work. This is the final picture of the DNA. The posted have to go to the library, and apparently it went to the library. The input, the high CQBL, the PLD, the QC1, all fails. So I don't know if they, I'm not sure if, Andy, I'm not sure if they sent to the sequencing, right? Probably not, because it's still failing high C, so this, yeah, and we received this sample, this big amount, and to put this in the, and we applied the nuclear isolation, and now we are going to follow the protocol that you are doing without that. So maybe we will have more success using the vertical protocol.
Which protocol do you use?
And the nuclear isolation first, and then the high C.
Because here you didn't use the nuclear isolation.
No.
I'm thinking, so the lichen is a symbiont with a bacterium, cyanobacterium, and the fungus. So on the bacterial side, they don't have any nuclei. So in high C, you are practically, by doing nuclear isolation, you're eliminating part of the symbiote. So then it should not be done. So it should be done as the challenging group.
Yes, we are going to try that. We have some sample in the lab now, so maybe we will go for it.
Yeah, lichens are nasty.
And do they have small ink?
Fungal genomes, I mean, the good ones are between, say, 20 to 80, but there are some nasty fungi, but they're mainly rusts and glomeruli, they are like up to 1 year. But basidiomycetes and ascomycetes that usually create lichens, they usually are not more than 100 megs. Of what I have seen so far, don't quote me on that. But usually they are small.
I don't have that many students to find it. If that happens.
Mycologist.
Really, that was.
We have prepped mycelium using the standard arena kind of thing. You see, it doesn't dissolve properly and all that, but because you probably need some other enzyme to do that. But you get the result in the end, actually, if you want to get some extra data for your assembly. Depends on how good your initial assembly is, how it will help you.
Yes, in VRBP, we tried 3 fungi and we failed that. You guys tried, but we decided not to proceed with them. It was phenomenal. Yeah. So, but finally we got a nice amount for all but one.
Yeah.
That was a bracket fungus. It was woody. So, and that was virtually impossible to work with. But yeah, DNA worked-ish. And it did not contain any RNA anymore in that light stage that was collected.
Yeah.
I also mentioned that for the fungi, you just do the archive and nothing, no IC or
Yes.
OBC.
So it's like that. We never run a standard down. Because they have so many samples, they do everything in parallel, both high C and high phi, or nanopore or whatever. We cannot afford that. We usually babysit our samples. So we first make sure that we have a good assembly, or if assembly needs to be scaffolded with high C. So when we see that assembly that we get from PacBio is already chromosome scale, so we can find telomeres and centromeres, then we do not do high C.
Okay. And this is not only related to the size, but maybe also to the fact that there are less repetitive elements.
Yeah, of course.
Because the size is something, well, this is small, but it's not so small.
No, exactly.
Compared to other invertebrates, for example.
Yes, exactly.
Mhm.
So we have a genome of the insect, which is a parasite on bee. High C failed there as well, but it was tiny, so it was an ultra low input. It was a better sample. So it's not just the size, it's the structure of the genome. Yeah. But also there we picked up like several Wolbachia genomes and the symbionts and everything else. So it was a nasty genome to start with. But it also was the smallest insect genome, it was I think it was 50 megabases, which is extremely small. I think that's the smallest insect genome.
Insect.
Insect, yeah. What was the name?